Well, first off, mine was in Java. So my first was a little bit more rigid, kind of a corporate experience,
Yeah.
but
Cold, meaningless.
Yeah. I was in a lab. Everyone was using CentOS at that, or CentOS, or however you say. I always called it CentOS, the fresh maker.
Yeah.
And so it's just like, I'm in this very cold.
That's nice.
Thank you.
Yeah.
I'm in like this cold, rigid environment with my Microsoft keyboard, programming away in Java. And I have just such this memory of despair because I love programming. This was after the linked list, and I cannot figure out recursion. And so I go to, the university store and I buy a book, and it's Dytel and Dytel Learn Java, and it has a section recursion. So I open it up and I start reading it, and it just doesn't hit home. And I'm spiraling into this maybe I'm not a programmer. Maybe I'm not worthy enough to enter into this circle of people who can figure out what the heck recursion means. And so Dytel and Dytel's like, I still remember this. Their exact phrase was, every young budding developer solves this recursion program. And it was the Tower of Hanoi. And guess what? I don't know if I can solve the Tower of Hanoi to this day. It's like a very hard recursive problem. And I just sat there and thought, oh my gosh, I'm not going to make it. And I sat there in the lab for 8 hours, 10 hours doing these things, so worried. It's the week of recursion. We have to do a lab assignment. I'm not going to be able to do it. And I just remember being like genuinely worried about that. And then, because my big problem was like, okay, do factorial. Why not just use a for loop? Okay, what about Fibonacci sequence? Why not use a for loop? Or like, I don't understand. What's the purpose of recursion? I don't understand it yet. It's so powerful. Why? It looks like a really complicated for loop. And so I just could not understand it. And then lab came that day, and it was, I'm going to give you a 2D array you have to read from a file. This is what a starting position looks like. This is what an ending position looks like. This is what a wall looks like. I want you to find me a path through the maze. And so I just sat there. I'm like, okay, well, I guess I can just go up and I can create like a visited grid so I know not to visit these places anymore. And then all of a sudden it just started clicking. I'm like, well, wait a second. I don't know the maze, but if I just go up, right, down, and left and hop back every time I've been to that square, don't visit it, like it will just go forever. And I realized in that moment, I'm like, I actually understand I've understood recursion this whole time. I just never had a problem in which it actually made sense to use. And that was like my big downfall, is that I was measuring my understanding with the problems that I had available, which were just, list traversal, which is not a good use of recursion. And so I just remember that freeing, oh man, recursion, it was a great moment in my life.
I mean, it does require, to be fair, a leap of faith, like, because people will tell you those, conformist, dogmatic Java instructors will tell you that this is, that's important to understand recursion, but it takes a leap of faith that this is a different way of looking at the world, and it's a powerful way of looking at the world. I actually remembered when I remember my first now.
All right.
I think it was Deb first search for one of the games, maybe Othello, something like that. And for that, implementing recursion. Understand that you can search trajectories through the space of states and do that recursively. That was mind-blowing. Just imagining like
you can just
the
see
possibilities.
It all.
Yeah, just like numbers flying. It was like The Beautiful Mind. And then, and that's when I also discovered conspiracy theories. That was, and I saw the truth